2023 was a wild ride. It started off with what seemed like a bear market, but ultimately ended pretty strong with, I don't want to say a bull market, but it seems like we were headed in that direction. With crypto prices skyrocketing in 2024 and all eyes seem to be focused back on the crypto market, the big question is, how can you make money in crypto today? The best way to make money in crypto in the blockchain industry is to become a blockchain developer. And one of the most important skills in blockchain development is smart contract auditing and smart contract vulnerabilities. In today's video, we're going to be going over the Ethernaut coin flip challenge and how to actually solve this successfully. My name's Anthony with the Blockchain Dojo, where we teach you how to become a blockchain ninja. Please like and subscribe and stay tuned for more content. And if you did learn something new, please consider dropping a subscription, a like, and ring the notification bell for more content. Let's get started, guys. So this is the Ethernaut coin flip challenge. What we do, we're going to start with is actually reviewing the smart contract, and then we'll go over the hack. So first, we see that the Pragma Solidity version is 0.8.0 higher, so we know that there is no overflow or underflow vulnerabilities available here. We look at the coin flip. We see that there is a variable to store the consecutive wins. We see we have a variable to store the last hash, and then a variable to store the factor. Now the factor is a random number that is used to help divide and calculate a new random number to use for the guess for the coin flip. Next, we have the constructor, which sets the consecutive wins variable to 0. And then finally, we have the flip function. Now the flip function takes in a guess, whether true or false, and then it would return a bool true or false, whether or not you guessed correctly. Now going over this, we can see that the block value has the block hash with the block number -1 cast to a uint256 variable. Next, this is just a quick check to see that the last hash and block value aren't the same. We reset the last hash to the current block value. And then this is kind of where the magic happens. So now that we know the block value, last hash, and the factor, what we can do is we can guess the coin flip, whether it's true or false, based on the block value divided by the factor. From there, the side or the correct guess would be equal to true or false, and then our guess is then compared against the side that the coin flipped on. Now, as you can see in the blockchain, we have access to all the numbers that they actually calculate the guess with. So we have the block hash, the block number, we have the factor, and we can actually calculate the coin flip and whether it would be a true or false number, meaning if it equals 1, if it's true or false, based on a few basic mathematical input. So going forward with that, this is actually our hack coin flip smart contract. So what we do is we set the coin flip contract as a variable. We then, of course, set ourselves as the owner, and then we copy that factor over. Next, we have our constructor, and our constructor takes in the coin flip address and then casts it to the coin flip contract that we had imported above. And then from there we have our function make guess. So what's pretty cool about this make guess function is it takes in true or false, and then what it does is it calculates the block value by doing the same calculations as the contract by casting the block hash with the block number -1 to a uint256 variable. We then take the coin flip by taking the block value divided by the factor, and then the bool side is equal to coin flip is equal to 1 or true or false. And then from there, what we do is, since we are able to calculate the math automatically in this function here, we then just take if side is equal to guess, we do coin flip dot guess dot flip, and then we submit our guess. Or if it's not equal to that, meaning that this value turned up false, we do the inverse of the guess. Now that we reviewed the smart contract code and the hack, what we're going to do is go over how to actually implement the hack and show you how it actually works. So first, what we do is we grab an instance and we grab the address. Then we come over here and we compile the smart contract, and we go over here to deploy the hack coin flip smart contract. Next, what we do is we deploy it with the target instant address. And then once we have the hack contract deployed, now that we have the hack contract deployed, what we will do is we will make a guess. And what we're going to do is I'm just going to make a guess of 1. We're going to come over here. We're going to process this transaction. All right, transaction's been processed. We're now going to come back over here to the Ethernaut page. We're going to do await contract dot consecutive wins. We're going to call this function. And then as you can see here, right here, we are at 1 consecutive win. And just to show you guys that this does still work multiple times in a row, we're gonna hack the contract again by calling the contract call and waiting for the transaction to process. The transaction's processed, and then we can come over here and we can call the consecutive wins contract or function one more time. And as you see, this number incremented from 1 to 2. And then one last example for you. Transaction's been processed, and boom, we're making that contract call again, and you see the consecutive wins has been increased to 3. Thanks for staying to the end. I hope you all learned something new. If you did, please consider liking, subscribing, and turning the notification bell on so you never miss a new video. We're constantly releasing new smart contract coding tutorials, programming tips, tutorials, and everything from Golang to blockchain to smart contracts to Solidity to tips and tricks. Thanks for watching. Stay tuned for more content.